Welcome to Unit 7. In this unit, we will be covering chemical reactions. We will be going into synthesis reactions, single replacement reactions, double replacement reactions, and decomposition reactions. So, what is a chemical reaction? A chemical reaction is when substances combine to form new substances, and this is represented through a chemical equation, which we will take a closer look at. Another way to think about this is that new bonds are formed between elements. Starting off with synthesis reactions, this is when two or more substances combine to form one new substance. This is shown by A plus B resulting in a combination of AB. This represents a typical synthesis equation where an element plus an element results in a compound. The reactants are on the left side of the arrow of a chemical equation, and these are basically your starting elements. The right side shows the products that result from combining the reactants in a synthesis reaction. It is important to remember that in a synthesis reaction, you start with two reactants that combine to form one end result product. An example of a synthesis reaction is shown here. The first element, carbon, is combining with the second element, oxygen, to produce a compound which is carbon dioxide. This reaction is showing two elements coming together to form one product, a perfect example of a synthesis reaction. The next type of reaction is a single replacement reaction. This is shown by the image of the equation below. This basically happens when one element replaces another in a compound. You start with an element, A, represented in the picture, and a compound made out of two separate elements, which is B and C. As you can see, they're bonded together. And guess what will happen to the products? It results in something different. It is still a compound and an element, but this time element A has binded with element C to form a new compound, and B is isolated as a separate element instead. This reaction is called single replacement because the element alone or single in the left side of the chemical reaction swaps with one of the elements in the compound in the left side of the reaction. Each time there are two reactants and two products. One is a compound and one is an element. In the products, the new compound forms and results in one of the elements in the old compound being isolated. Let's take a closer look at an example. This example shows two reactants, zinc, which is the singular element, and hydrogen chloride, which is made up of two separate elements, hydrogen and chlorine. The products of this chemical reaction after the arrow show zinc binded with chlorine to form zinc chloride, and hydrogen is left over as the single element. Next up are double replacement reactions. This is similar to single replacement reactions, but instead shows two compounds switching to form two new compounds. The elements that make up these compounds is what switches around. As shown by this top equation, AX and BY represent two compounds which each have their own two elements, with A and X binded together and B and Y binded together. The resulting products show that the elements switch around and bond with each other to form two new elements, AY and BX. So as shown in the image in the bottom here, if AB is a compound combining with CD, another compound in a double replacement reaction, what do you think will be the result? That's right, the elements will switch around to form AD and CB. Typically, in a double replacement reaction, the first element and the last element on the two separate compounds will combine in the products, and the last element of the first compound and the first element of the last compound will form the second product. Be sure to remember, in double replacement reactions, two compounds form two new compounds. Here is a real double replacement reaction with a chemical equation shown. The reactants show sodium sulfide made up of the elements sodium and sulfur, and the second reactant is hydrogen chloride made up of the elements hydrogen and chlorine. The products show the compounds after they have switched elements. Sodium is separated from sulfur and binded with chlorine instead to form the first product, sodium chloride, and the second product shows the hydrogen element bonding with sulfur to create hydrogen sulfide, resulting in the two compounds resulting in two new compounds. And lastly, we have decomposition reactions. In decomposition, the reactant is just one compound. The resulting products show the compound being broken down into two or more products. And the products are the elements that the compound is made out of. This image, for example, shows a potential compound made up of the elements A, B. The result will be the products A and B separately. This represents how a compound is broken down into separate elements during decomposition. This last example shows a decomposition reaction with real elements. This shows the starting reactant on the left side of the equation. The starting reactant is the compound aluminum oxide made up individually of the elements aluminum and oxygen. After the chemical reaction, the products show aluminum and oxygen separated. This is essentially how decomposition works. It is important to understand and be able to recognize these types of chemical reactions as they are essential in understanding chemical equations, which you will learn about in the future. Great job on this lesson. See you in the next unit.